In our first example, we're looking to calculate the volume of a basketball to the nearest cubic inch. Now, a basketball is a sphere, so we're going to begin with the formula for sphere, and we need to find the radius. We're given the diameter, so we can divide that in half, and when we do that, we've got the value of the radius. Keep the exact value until we get to the end. We're going to substitute that in for r, for radius, and then when we do this, we can type this into our calculator just 4/3. You might want to remember that you have to put the 4/3 in brackets, times pi times 4.695 cubed, and then we're going to get 433.50, etc. But this particular question wants us to round to the nearest cubic inch, so we can see we're going to round off to this place. The number after is 5, so that's going to bump up this 3 to a 4, and we always use cubic units when we're dealing with volume, so we're going to have 434 cubic inches. In our next example, they give us the volume of a pyramid, as well as the length of the base and the width of the base. So it tells me that the base is probably a rectangle, so I have a rectangular pyramid. So the first thing we're going to do always is draw a sketch and then label the dimensions that we're given. Now in this particular question, we're looking to figure out what the height of that pyramid happens to be. We're going to begin with the formula for the volume of a pyramid, and then we're going to substitute in the information that we do know. So in this particular case, we know that the volume is 1,000, we know the length, we know the width, and we know that we're looking for the height. So we have an algebraic equation now where our goal is always to isolate that variable. In order to do that, I'm going to begin by getting rid of that denominator. So dividing by 3, if I multiply by 3, I'm going to eliminate that 1/3. And we'll be left with 1,000 times 3 gives us 3,000 on the left, and then 20 times 15 times h leaves us with 300h. Now again, our goal is always to isolate the variable, so in order to do so, we're going to divide out that coefficient of 300. 300 divided by 300 leaves us with 1h, and 3,000 divided by 300 is 10. And then make sure you include the appropriate units. So because everything else that we're given is in centimeters, we know that the height is going to be 10 centimeters. When dealing with composite objects, we have 2 or more objects put together. We're going to calculate the volume of each and add them all together. Unlike surface area, we don't need to worry about taking off certain pieces. If you imagine we have a cylinder, we're filling it all up with water, for example. We have a cone and we're filling it all up with water as well. When we put the 2 of them together, the volume is going to be the amount that fills up both objects. So we're just calculating the volumes and adding them together. So we recognize that we have a cylinder and a cone. So we're going to begin there by writing down the formula to find the volume of a cylinder, and then writing down the formula to find the volume of a cone. For my cylinder, pi is a constant. I'm given the diameter of the cylinder is 19 feet, so half of that will give me the radius. So if we divide by 2, 19 divided by 2 will give me the radius, and we can see that the height of the cylinder is 21 feet, so we can substitute those in. Now in terms of the cone, we have pi times r squared times h. So pi again is a constant. The radius will be the same, so it's going to be half the diameter that's given to us, so 9.5 feet. Now the height of this cone, we know that the height of this whole object is 25 feet, and the height of the cylinder is 21 feet. So if we subtract 25 minus 21, that's going to give us the height of the cone, which is going to be 4 feet. So we can go ahead now and substitute those measurements in there. And when you enter this into your calculator, I first just worked out pi times 9.5 squared times 21 to get the volume of the cylinder. And then with the cone, make sure that you put the numerator in brackets and then divide by 3. Or you can also type in pi times 9.5 squared times 4 equals, and then divide that whole value by 3. Add the 2 together, and it doesn't say what to round to, so I'm going to leave it as an exact value. And volume always is measured in cubic units, in this case cubic feet. And in our final example, we're looking for the volume of the silo, which is made up of a cylinder as well as half a sphere on the top. So I'm going to begin by saying, okay, we need the formula for volume of a cylinder as well as the formula for volume of a sphere, and we're going to take half of that. So I'm going to write those formulas down, and then if we begin with the cylinder, again, pi is a constant. I know the diameter is 45 feet, so that's the diameter across here. I'm going to divide that in half to get the radius, and we can also see that the height of that silo is 65 feet. So we're going to substitute that in. So 22.5 squared times 65, that's going to give us the volume of the cylinder. And then we're going to take half the volume of the sphere. And again, with the sphere, we have the same radius, so it's going to be that 22.5. And then when you go to put this into your calculator, you need to figure out what this volume is, and then we're going to take half of that. You could just enter this and then divide by 2. You need to remember 4 divided by 3, I'm going to put that in brackets, and then we're going to multiply by pi, and then we're going to multiply by 22.5 cubed. Please make sure that you're able to correctly enter this into the calculator. The volume for half the sphere comes out to be 23,856.46, etc. We're going to add that to the volume of the cylinder that we already determined, and it doesn't say what to round to, so again, we're going to leave it as an exact value, 127,234.502, etc. cubic feet.